Okay, welcome to the probability review. This is page 2, maybe page 2 and 3. Question 3, for each term identify 1, the number of trials, 2, the probability of success, 3, and the number of successes. So when we're looking at this first problem, the number of trials is 15. And the number of trials here, this should be a 22. And here's why. These two numbers always have to add up to the total. The number of successes plus the number of failures equals the total number. 9 plus 13, 22. All right, next. The probability of success is 2/9. And for part B, 0.22. And third, the number of successes, 8 and 9. That's our random variable X. All right, an airline claims that 94% of its passengers with tickets usually show up for the flight. The airline overbooked a flight by selling 140 tickets for the 124 aircraft. So this happens a lot of times. Airlines sell more tickets than they have seats, hoping that a certain percent don't show up so the plane is still full. What is the probability the number of passengers show up is between 100 and 124 inclusive? So we're looking for this probability. This is a binomial because I have a fixed number of trials, the 140 tickets sold. I have a probability of success. That's the 0.94 success rate. And I have a random variable in that range. So the way I find this is the probability that X is less than or equal to 124, and I subtract the probability that X is less than or equal to 99 because I want to include the 100. Both of these are binomial probabilities, so we're going to find each one separately. So these are cumulative. So I go to my second distribution, binomial CDF, 140 trials, 0.94. I'm typing it in right now. This first number is about 0.01011 when you round, and the second value is 8.89 times 10 to the negative 18. So this is really rare, right? The second probability, this is not likely to happen because it's so close to 0. Well, what that means is when you take this first probability and subtract, you're still really close to this first probability. So 0.01011. Okay, number 5. A baseball player has a batting average of .280, so that's the probability of success. So far, we do not have a fixed number of trials, but hold on. In part A, this is binomial because there are 10 times at bat. That's my 10 trials, and X is my random variable. I want X to equal 4. So this is the probability that X equals 4 with a binomial probability. I have the probability of success. Now remember, this is a binomial PDF. So I have 10 trials, 0.280 is my probability of success, 4 is my random variable, 0.1798. Fewer than 6 at her next 12 at-bats. Now N equals 12. Also, you want fewer than 6, so that's the probability that X is less than or equal to 5. This is a binomial CDF. This is cumulative. So we take our 12 trials, take our 0.280, that's our probability of success, and we subtract off the random variables 0 through 5, because that's fewer than 6. Here we get 0.91129 when you round. Okay. C is different. We do not have a fixed number of trials. We have a first success. This is geometric. So her first hit is on the 6th at bat. So that means you have to fail 5 times and then succeed once, in that order. Now, how do we find this rate? Well, it's the opposite. It's the complement of 0.280. So it's 0.720. So that these two are complements. They always add up to 1, right? So 0.72 to the 5th times 0.28. This is really close to 0.05417. So we'll say 42. Number 6. You are about to take a multiple choice test with 40 questions. Each question has 4 possible choices. Well, if you're randomly picking a choice, you have a 1 in 4 or 25% chance or 0.25 probability of success, right? You know your number of trials is n equals 40. So this is, so far, a binomial distribution. All right, what is the probability of getting fewer than 15? So probability that x is less than or equal to 14. So we do a binomial CDF, 40 trials, 1/4 success, all the way up to 14 because it's fewer than 15 correct. And this is most likely, this is pretty high, right? High means close to 1. What is the probability of guessing more than 10 correct? Well, that's x is greater than or equal to 11, more than 10. That's 1 minus the probability that x is less than or equal to 10. So with the 1 minus, I get 0.41609, so I'm going to say 61. All right. C, what is the probability of guessing between 8 and 12 inclusive? So probability 8 is less than or equal to x, less than or equal to 12. Is the probability x is less than 12 minus the probability that x is less than or equal to 7. So we did one like this just a few minutes ago with the airlines. So we're just going to give you the answer real quick. This is a binomial probability. Probability of success is 0.25. All right, and I get the final answer, 0.63. It's like 8911. So we'll say 89. What is the probability of getting fewer than 8 or more than 12? Well, fewer than 8 or more than 12 is the opposite of what I just asked. So it's 1 minus probability that x is between 8 and 12. So it's 1 minus 0.6389. All right, so let's figure that one out. So 0.6389. We get very close to 0.3611. All right, number 7. The probability of rolling doubles on a 2 fair dice is 1/6. In the alternate rules for the game of Monopoly, a player can pay $50 to get out of jail or attempt to roll doubles. A player rolls the dice 8 times. What is the expected number? So that's the mean, or the expected value. So out of 8 trials, that means we have a binomial distribution. It's n times p, 1/6 times 8. That's 8/6, 4/3, 1.3. So in the long run, if you roll the dice 8 times, on average, you'll get about 1.3 repeating doubles out of 8. B, the player rolls the dice until the first doubles appear. Okay, now this is geometric. All right, so the mean is 1, or expected value is 1 over the probability, 1 over 1/6, or 6 rolls before you get your first doubles. Find the probability that the player rolls doubles on the first try. Well, that means we have geometric. Probability x equals 1 is just 1/6. Find the probability they roll doubles on the 4th try. So probability, that's also geometric. Probability of x equals 4. So they had to have 3 failures, 5/6 cubed, and then 1/6 to the 1. All right, times 1/6. I get about 0.0965 when I round. Very good. Thank you.